All right, so now let's talk about motion. Like it says right here, motion is just a change in position with respect to time, right? And that sounds like a very formal definition, but just think about it. That's all motion is you got to get from point A to point B, right? You're just changing in position from point A to point B, like you see this elephant here in this GIF, right? He's just going from point A to point B. And like it says here, you must have a reference point, right? So if you're going to have motion, you have to have a starting off point. Without that, you really don't have any motion, right? Because again, point A to point B. And so a reference point is just an object that is used for comparison, and it's assumed to be stationary, right? So here you can see on the graph that he's starting off right there at point A, and he's getting to point B at an average speed of 7 meters per second, right? And we'll talk about a speed right now. But again, motion is just going from point A to point B with respect to time, right? So you have to have some kind of account for time as you're going from point A to point B. Again, this elephant right here is just saying in 7 meters, sorry, he's moving 7 meters per 1 second. And that's actually kind of fast for an elephant now that I think about that. But yeah, he's moving 7 meters in 1 second. Right, so speed is very much related to motion. Speed is just a measure of the distance traveled per unit of time. Basically, that's just saying how fast something is moving. Right, so speed is broken down like this, and we're going to have to do some math when it comes to calculating speed. So just know that speed is equal to distance divided by time, and that makes sense, right? Because that's what speed is getting from point A to point B, but knowing how fast that happens, right? So remember when you see a formula like this, when you see a math problem like this, it's actually telling you something. It's like a sentence, right? But it's a lot simpler than that. So if you think about it, right, your speed is like it says, it's distance, but you take that distance and you divide it by the time, right? So how much you traveled in a certain amount of time. So this is a formula is S equal D divided by T. Speed equals time divided by distance. Sorry, speed equals distance divided by time. And so here you see it written out. And in this case, the question here, the example is asking you, what is the average speed of this car if it travels 1,600 kilometers in 10 hours? So right there, they're giving you the distance, which is 1,600 kilometers, and they're also giving you the time, which is 10 hours. So all you got to do is plug those in right there, and you see this, that, let me get the highlighter out real quick. So right here, you have this distance, and you just plug it in here, distance, right? And here you see they plugged in that 1,600 kilometers. Then next you have the hours. So here, 10 hours, right? So not a very good, doesn't really show up too well there, but 10 hours, you put it down here as a denominator, time, and here you see they put that 10 hours down here. So basically, it's just 1,600 kilometers divided by 10 hours, and that gives you 160 kilometers per hour. So that's saying that in 1 hour right here, in 1 hour, this person traveled 160 kilometers. Right, and it's just a simple division problem, but you can rearrange it to solve for other things in here. So if you're looking for distance, you can rearrange it and solve for distance. If you're looking for time, you can rearrange this formula right here and solve for time. Right, and we will be seeing some of those in our example problems. So there are different types of speed. You have constant speed. It's when it's traveling at the same exact speed for a period of time, right? So the example is a ship traveling across the ocean may move at the same speed for several hours without changing that speed, right? So that is a constant speed. You'll see these types of things in like astronomy when you're talking about like different types of planetary like bodies like meteors, comets, things like that. They'll travel at constant speeds, and they'll just keep traveling at that speed. Even planets and stars and things like that. Average speed, most objects don't move at a constant speed for very long. Like generally it changes. And we'll learn about this when we talk about Newton's three laws and how there are things called friction that pretty much does not allow things to keep moving at a constant speed forever on our planet. In space, that's more likely to happen, right? Something up in space could just travel forever and ever and ever and not ever stop, not ever slow down or speed up if it doesn't run into like a planet or a star or some kind of gravity pull from one of those. But an example of this is like a marathon runner travels fast downhill and slow uphill, right? So there are different speeds, but you just calculate it. And then instantaneous speed is just a measure of speed at any given moment, kind of like what you see in your car speedometer, right? You look at that and it tells you how fast you're going at any given moment. All right, so we were just talking about motion and then we talked about speed. Now let's talk about velocity. So velocity is speed, but in a particular direction, right? So remember that because you may see that again. Remember that speed is how fast you get from point A to point B. Velocity is basically the same thing, but moving in a certain direction. So speed and direction of motion. The example that you have here is a storm moving 25 kilometers per hour. But the important part here, remember, if I would have just said a storm moving 25 kilometers per hour, that would be speed. But because I mentioned this part right here, eastward or no eastward direction, that then becomes velocity, right? So very similar. Can you have two objects that have the same speed but have different velocities? If so, how, why, or why not? And this GIF that I included right here actually shows you the answer. You see, this actually looks hectic, right? This is almost like Austin traffic, but you see people moving in all kinds of directions. And so the answer is, yeah, you can have the same speed but different velocities. If you have two cars traveling at 55 kilometers per hour, but they're coming in opposite directions, then yeah, they have the same speed but different velocities, right? And so again, this GIF right here that you see, tons of people moving, probably at the same speed and definitely in different directions. Right, so changing velocity. Name two ways in which objects can change velocity. So it can change velocity by slowing down or speeding up, or it can also change velocity by the direction in which an object is moving, and then it changes. Right, those are ways that it can change velocity. And so when you calculate velocity, the good news is that it's pretty much just like speed, only you're going to add a direction to it, right? So the formula is the same. Remember, we talked about speed equals distance divided by time, and it makes sense, right? It's just how much distance you travel in a certain amount of time. So again, it's like a sentence, but it's broken down into just three simple variables, right? Speed, distance, and time. And so again, it's speed equals distance divided by time, or if we're talking about velocity, it equals distance divided by time, but you also give a direction, right? So we'll see that right now in a second. So let's try out this example right here. Find the velocity of a truck that travels 75 kilometers north in 2.5 hours, right? So basically, this is just like our speed problem, except here they are giving you this right here. And they actually put it in that orange color, and I'll just highlight it again. They're giving you the direction, right? So again, pretty much just like speed, like it shows you right here, distance divided by time. And we see that the distance here is 75 kilometers. So this is going to be on top, right? This is a numerator. And here the denominator, the one on the bottom, is 2.5 hours. So you see again, the distance, 75 kilometers, is on top. 2.5 hours is on bottom, right? And again, the top is called the numerator. The bottom here is called the denominator. Right. And then when you put those in there, it's just division. Whenever you all see a fraction, fractions are basically just division, right? You just divide the top number by the bottom number. And in this case, you're seeing that 75 kilometers divided by 2.5 hours is 30 kilometers per hour, right? But that would be speed. That would not be the answer for velocity. This would be incomplete for velocity unless you add this right here, all caps, exclamation point, and I even underlined it here twice, north, right? You got to give a direction if it's velocity. So 30 kilometers per hour north, or you could say 30 kilometers per hour in a northward direction, or 30 kilometers per hour northward, right? You have to make sure to give that direction.